welcome to this webinar here, Make or Buy Industrial Ethernet for Automation Products. Before I hand over to my colleague Jürgen Lange, who's going to cover here the main part to answer this question, I'd like to provide just a very quick market recap, a quick look at the market situation. Yeah, why are we discussing this question here in the first place, make or buy, and not, let's say, industrial Ethernet, yes or no? Let me start with just a few spotlights on the industrial automation market in general. A first basic observation: I guess it's fair to say that most innovation for industrial automation nowadays is driven by software and information technology. Yeah, you see a couple of examples which I collected here on the slide. The diagram in the upper left-hand side here, let's say, symbolizing everything that has to do with innovation and advanced algorithms, machine learning, artificial intelligence, often tied to cloud-based computing. So this is one aspect here, how innovation is currently driven. Another image here showing, let's say, at least the potential of virtualizing PLC technology here, offering more flexible, maybe more cheaper ways to work with PLCs, to reconfigure, to update, and so on. Then, of course, we have industrial Ethernet, a trend. When you Google it, it's not complicated at all to find here some statistics and report which talk about growth in the past or future growth to be expected. You can even count in aspects like an increased use of consumer devices, tablets, or mobile phones, at least for some applications, to operate the plant. So that's here the first basic observation, a very general observation. Innovation is software IT driven, and industrial Ethernet, or the adoption of Ethernet, is one example among others. Now, taking a closer look at Ethernet and why it's becoming more and more widespread. Here on this slide, first observation: this is of course not only true now for industrial automation. You have an increasing adoption. You see an increasing adoption of Ethernet in other verticals. You see it, as this diagram shows, also, for example, within cars, connected vehicle, software-defined vehicle, some buzzwords. Of course, one reason why does it offer so many opportunities, and why do we see this trend now also for industrial communication? It's the fact that Ethernet is becoming a standard in many, not to say all, technology layers which are relevant now for modern solutions. Yeah, again here an aspect of the diagram. So of course it's also being used on enterprise IT level, where you have now the complex software applications. It's used here for connectivity. Here the term service providers here relates to how to set up connectivity, maybe also now over 5G or mobile networks. And of course, all the aspects related now to central platforms, hyperscaler, cloud, and edge computing. So you have here Ethernet as a standard across multiple industries, different market segments, and also across multiple technology layers for new and modern solutions for industrial automation, or IoT, you could say. And the driver behind it, really, in most cases, why is this attractive, is actually cost efficiency. Yeah, in some cases, I mentioned new modern algorithms. Maybe you have additional functional aspects which are made possible, but in many cases, the driver really is the potential that Ethernet makes operation cheaper. And you benefit from economies of scale. The entire IT industry is just so much bigger than the automation industry, that the automation industry benefits from cost benefits here. This, when you look again here at some numbers, you know, this is something that can be proven by market research and numbers. So you see here a first chart which shows the development in the past 10 years, where you have a strong rise in the adoption of the industrial Ethernet. wireless more or less constantly as an alternative physical layer. And yeah, industrial Ethernet, as expected, is gaining market share here, taking it away from more traditional non-Ethernet based field bus communication systems. And this trend is expected to continue in the coming years here. The diagram at the right-hand side showing how the market is expected to grow here for the next 5 or maybe even 10 years. Looking at what's going on regarding standardization, this is backed up by standardization initiatives which leverage or use here the Ethernet protocol as a base technology. Examples include OPCA or OPCA for field exchange, tightly coupled with real-time capabilities for OPCA over TSN. So this is one driver for Ethernet or match with Ethernet. Maybe more recently, also the introduction of Ethernet-APL here, a physical layer for process industries, extending Ethernet-based communication in process industries, including X zones. A last slide before I'm done with the quick market recap. Now, if you take a closer look at industrial Ethernet, what protocols are available, what does it mean for you? Let's say you're a device manufacturer and you say, yes, now it's the time here to integrate here industrial Ethernet in my devices. It's not that easy, as obviously there is not the one and only protocol using industrial Ethernet. Of course, we all know there are quite a few. You see here a chart, PROFINET, Ethernet-IP, EtherCAT, and quite a few others. Again, what market research and what numbers show is that you have a certain consolidation around 3 or 4 most relevant protocols based on Ethernet. Yeah, and those 4 are PROFINET, Ethernet-IP, EtherCAT, and also Modbus. Yeah, and again, when you Google it or when you research, you find a couple of reports here. We picked one indicating that about 80% of all communication is Ethernet-based. You have other reports which show similar numbers, maybe even a bit higher number than 80%. So that's, you could say, good news that you are not faced with tens or even more protocols if you want to somehow cover the market, but a few selected protocols will allow you to cover also the vast majority of applications or potential customers. So that's the quick recap. One more slide before I hand over to Jürgen really quickly, as we cannot assume that all of you know Softing. We are a German company, Mittelstand, as we say in Germany, a small mid-sized company, around 400 employees, based just outside Munich in the south of Germany. Underneath the holding structure, there are 3 business units, and we represent here Softing Industrial, shown at the right-hand side. And the topic we are covering today is one of 3 segments we are working in here, shown at the bottom right. We like to call it technology integration, where we sell software hardware components to manufacturers. We also have business with end customer products, where we actually use our own technology integration products, mutual benefits here. Yeah, so this is Softing, and with this, Jürgen, I hand over to you.
Yes, make or buy, in-house development or buying a ready-made solution. We will look at technical, functional, and commercial aspects and see that there are several options for a ready-made solution. In order to approach the make or buy question, we will take a look at various criteria. The first key question is whether the product you want to integrate industrial Ethernet already exists, or will it be developed from scratch? Can I only integrate a portable stack because the hardware cannot be changed? Or is it a possibility of a hardware redesign? If yes, which option is the most suitable? How quickly do I get to go to market with a new solution? What about my resources? Do I plan to implement one or several protocols? Data volumes, time requirements. Let's take a closer look to this criteria. Well, number one, that's what's the situation for me as a manufacturer of automation products? Do I have necessary knowledge in the company? Is data communication, industrial Ethernet part of my core competence? Do I want maximum independence from third-party suppliers? For example, it's company philosophy to develop everything myself. Or do I have the development resources? Do they match my time to market planning? How about my finances? Depending on the answers of the previous questions, it may be cheaper to develop in-house. Or are there any strategic reasons that influence the make or buy decision? Next, let's have a look on general requirements. Time to market. Well, there is no question that a use of a ready-made solution is far superior to an in-house development. Do I want to integrate industrial Ethernet into one or more products? Well, if there are several, it might be worthwhile to build up resources and knowledge in my house. CapEx versus OpEx means one-time investment in my products versus recurring costs during selling my product, for example, license fees, module costs, etc. In other words, do I want to build a house or do I want to rent the house? The value of my product or product price, it's a criteria. A functionality-rich module may be oversized for a 100 euro temperature sensor and also too expensive, while this might be feasible for a safety device. Also, geographical target market is a topic. In Europe, there's no getting around PROFINET. In the United States, we need Ethernet-APL, and in some industries, EtherCAT is standard. So then the question is one or several industrial Ethernet protocols. Number 3, technical requirements. What data volume do I want to be able to transfer, and what is the required performance? Are there hard real-time requirements for control tasks, or it is sufficient to transfer a few values once a minute? As a rule, we need the appropriate hardware equipment for high-performance data transmission. This can be achieved in software with a sufficiently powerful microprocessor, but it's unproblematic with communicating the software when the software is processed deterministically in a module, an ASIC, or in an FPGA. There are many examples with a software-based solution. Let's take the temperature sensor from earlier. Price and space in the sensor play a central role. Then communication stack, maybe a light stack, must be adapted to the processor and operating system. But there are also other technical requirements such as cybersecurity and safety. And especially cybersecurity is playing an increasingly important role, which I will discuss later in this webinar. Let's have a look on this slide. We see that there is a considerable complexity, definitely a challenge for me as a product manufacturer. For an overall view of the make or buy decision, we do not have only to consider the development. We must also consider production and, very importantly, maintenance. Maintenance over many years in order to keep pace with market requirements or legal specifications or customer requirements. Only then we can estimate the total costs of ownership. Due to time constraints, I will not go into details of each individual phase. But however, it is clear that harmonization of the task makes a lot of sense. Standardization, ideally one hardware architecture for the entire product family, the same processor, the same operating system, the same toolchain, the same application programmers interface, the interface for different industrial Ethernet protocols, etc. With this slide, I would like to give you a general overview of various implementation options. This is a qualitative comparison, not a quantitative statement. Roughly speaking, it shows the strengths and weaknesses of each option. Let's take the portable stacks. In terms of operating costs and price per license, they are unbeatable. However, the stacks we will have higher development effort and correspondingly longer time to market. The risk of errors is higher than with a solution encapsulated in a module or FPGA. If we look at the modular approach, we can clearly see the strengths due to the low integration effort. The complete tested and pre-certified functionality is encapsulated. Only a few pins need to be connected to my target hardware. This results in a correspondingly short time to market. At the same time, there is a high degree of expandability with functions or protocols. And the situation is similar with the realization based on FPGA. Low integration effort, fast time to market, tested stacks, real-time capable, switch IP core, encapsulated within the FPGA. And that's not to be adapted to my target hardware. The stacks, for example, customer-specific proprietary protocols can easily be added. Several protocols can run simultaneously in one FPGA, or different images can be created and loaded for different flavors of my product. Well, the great thing is that FPGA technology has been established standard for since the 1980s. There are major development tools, and you can buy different scalable FPGA components. FPGA is kind of programmable ASICs. The advantages: flexibility. It's very flexible. So, but also performance, low development cost, short time to market, fast adaptation to market and customer requirements are the advantages. Well, a first interim summary of the make or buy question. How do I arrive the best optimal solution for my product? The make approach may have an advantage here. Very specific requirements can be customized by your own development. With a buy approach, that might not be possible or maybe only difficult to realize. In terms of control and independence of a third party, the make approach also has clear advantage. If the company's philosophy is to develop everything itself and knowledge and resources are available, then make is the way to go. But the situation is different if the company's philosophy focuses on the core competence, for example, the classic machine builder. This is where the impressive advantages of the buy approach come into play. Shorter time to market, early turnover, high cost savings in development, minimized overall costs. Expandable for new technologies and market requirements. Well, of course, I can implement extensions myself, but normally extensions are made available as part of the product maintenance of a stack, a module, or the FPGA with a buy approach. No additional effort for the product manufacturer, no additional investment. In many cases, a make or buy decision can be made relatively quickly, as some criteria are simply so obvious and compelling, as mentioned before. But in many cases, it is necessary to go more into depth, and this is where professional advice makes sense. At this point, I would like to introduce you to a very comprehensive offer from Softing. It starts with the opportunity to advise you on the most suitable implementation option for your project without any conflict of interest. No conflict of interest because we have both software and hardware-based implementation options in our house as standard solution for the 4 most important industrial Ethernet protocols, which can be offered as a portable stack or on FPGA basis or as a module. 3 ready-made solution options from a single source proven architecture, simple API for PROFINET, Ethernet-APL, EtherCAT, Modbus TCP. 1 consultation, 1 integration support. We help our customers to realize the optimal solution for the product, from consulting and planning to development and certification, including maintenance. I mention maintenance in particular because the legal requirements and market demands in terms of security have increased massively and are very dynamic. Security in sense of either cybersecurity and cybersecurity, but also safety. Let's have a look on cybersecurity. The Cyber Resilience Act, and as a result, the IEC 62443 standard pose quite a challenge for product manufacturers in Europe. In short, the European Union wants to ensure that products on the European market are protected against hacker attacks, sabotage, and manipulation, and thus prevent serious damage when these products are used. So Softing positioned itself for this at an early stage. We are certified according IEC 62443, and our agile development processes with the new cybersecurity requirements of this IEC standard have been running for over a year. A complex matter and a significant investment, but our customers will be grateful if the data communication of the products is secure as a result. HEMA controllers are a very good example of a safety application with PROFINET. The Softing PROFINET controller stack is used here on a HEMA hardware architecture. And this HEMA architecture is identical to the Softing real-time Ethernet module architecture. This allows HEMA to import updates one-to-one without any adaptations. This reduces total cost of ownership significantly. We will go into more detail in this HEMA solution in another webinar. Finally, let me evaluate the Softing solution as an example of the buy option. The Softing solutions are flexible and scalable in terms of software, module, or FPGA approach. They are also flexible, scalable according to customer requirements. A good example of this is the pump manufacturer Grundfos, which uses the Softing real-time Ethernet module. In addition to the Softing industrial Ethernet protocols, two other protocols are used in the module which Grundfos itself provides. The solution has been functionally extended by connecting a proprietary Grundfos protocol. A good example. Another good example is a product example is a customer, a sensor manufacturer. Their PROFINET Ethernet-APL, EtherCAT, and Modbus TCP were integrated into a sensor application via the standardized API. Depending on the target country and the customer application, the sensor is customized during production. For example, firmware with the PROFINET, Ethernet-APL, etc., is flashed into the sensor. Do you remember the slide showing the complexity of development, production, and maintenance and the impact on the total cost of ownership? Standardization is the keyword. And maintenance included, we monitor the market and the legal requirements for our customers, and we keep our protocols up to date. So no dependency on static ASICs, expansion also possible after production. And the beauty of portable stacks of FPGA solutions is the flexibility, reprogramming, functional expandability. Reconfiguration and firmware download, that means flexibility also in the field. You can implement solutions that adapt dynamically to new market, legal, or customer requirements. And the keyword is pre-certified. Well, Softing has the test equipment and test tools used by the certification bodies. We can reproduce the automated tests of the certification laboratories one-to-one. This enables us to optimally prepare our customers for the final certification. For example, by advising them on possible deviations and what measures to take to prevent them from failing certification. Well, the Softing offer is an all-round carefree package with consulting, tech support, and services on demand. And it is cyber security and safety ready. So Softing's buy solution is flexible, economic, and future-proof.
So there is a question with regards to the fact that there was consulting and services mentioned during the presentation. Would it be possible to expand on what that actually entails? Maybe to you, Jürgen.
Yes, well, I mentioned it's a full solution, starting by, let's say, consulting what's the best solution for you as a product vendor. And we do kind of technical pre-sales evaluation, and during this evaluation, we check different criteria, technical criteria. When the customers has made a decision to jump on our solution, we can begin with a kickoff workshop or 2 kickoff workshops, so really introducing into the Softing solution, and we can help a customer designing in our either stack or modular FPGA based products with ongoing tech support via Teams or via telephone, via email. And this can be done until, let's say, final certification and go to market of the customer products.